Hello everybody and welcome to Rational Science. We have an exciting day today. We're going to be dealing with the alpha and the omega, the beginning and the end. Now it turns out that both Christianity and relativity have the same starting point. In the beginning. That's how they both begin. That's how the catechism begins in both these disciplines. And the question for you today is, was there a beginning? Can you imagine a beginning? Okay, so we have a beginning. Will there be an end? An omega? Will there be an omega? Will there be an end? And the reason I raise that issue is that, here we are. Humans, we're intelligent species and we can understand a lot of stuff, we can project stuff, and we're aware that there's gazillions of planets out there in the universe. Certainly, there's got to be another civilization, at least similar to us, somewhere in the universe. And the question is, why haven't they contacted us? It's an issue that is under an umbrella type question or issue known as Fermi's paradox. Why hasn't anyone contacted us? Okay. I mean, you would think someone is a little more advanced than us, maybe technologically or whatever, they would be able to get in touch with us. And no one apparently has done so. Okay. So this is one of the things that you got to think about today. Anyways, why did I choose that for today's lecture? Because here we have the Nobel Prize in 2019. It was given to these gentlemen. First one is Jim Peebles, who talked about the alpha almost all his life. And then we have these other two fellows from Switzerland, and they got the Nobel, or they split the the silver medal, okay, for discovering the first exoplanet. In other words, the first planet outside the solar system, Jupiter-sized type of planet, okay. And so the issue is, again, there are other planets out there. Apparently, they have discovered like 5,000 or 6,000 more planets since then. That was in 1995, so it's been, 25 years now? They've discovered a lot more planets out there. And the question is, are any of those planets inhabited with intelligent beings? And if so, why haven't they contacted us? Why don't they answer our telephone? E.T., come home, Okay, so this is the issue that we want to explore today. Okay, let's go with Mr. Peebles first, okay? He's been around for quite a while. He got his Nobel finally, okay, because, again, he's been there for quite a while. He's an expert on cosmology, especially Big Bang and what happened, especially immediately after the Big Bang. He's been studying that issue for at least 100 years, I would say, okay? And so who is Mr. Peebles? Well, here you get a little summary, okay, from the literature. It says, James Peebles' insights into physical cosmology have enriched the entire field of research and laid a foundation for the transformation of cosmology over the last 50 years, from speculation to science. Okay, well, thank God we have someone who does a little science and no more speculation, okay? His theoretical framework, developed since the mid-1960s, is the basis of our contemporary ideas about the universe, okay? R means mathematical physics, okay, by the way, okay? The Big Bang model describes the universe from its very first moments, almost 14 billion years ago, when it was extremely hot and dense. Since then, the universe has been expanding, becoming larger and colder, barely 400,000 years after the Big Bang. The universe became transparent and light rays were able to travel through space. Okay, we have light rays traveling through space, whatever light rays are. Using his theoretical tools and calculations, James Peebles was able to interpret these traces from the infancy of the universe and discover new physical processes. Again, he's talking about Big Bang. There you see it on the lower right. Okay, and he's also a black hole and a dark matter expert, and you'll see those two on the bottom left. And so he's been studying this stuff for, again, 30 years. Okay. The results showed us a universe in which just 5% of its content is known. Only 5% of its content is known. What's the rest? Well, the matter which constitutes stars, planets, trees, and us. The rest, 95%, is unknown dark matter and dark energy. So whenever you hear dark matter, dark energy, it's a measure of ignorance. Okay, so these people, the mathematical physicists, they claim, they confess that they are 95% ignorant, only 5% knowledgeable. Okay. This is a mystery and a challenge to modern physics. Okay? James Peebles' theoretical discoveries contributed to our understanding of how the universe evolved after the Big Bang. Okay? Uh, yeah, that's if you accept that there was a Big Bang. Okay, so let's see where this leads. Let's see if we can find out how it happened. That's what I want to know, at least, right? Okay, I think you might have the same concern. How did it happen? I want to see the process here. Okay, where did he get this anyways? Well, it turns out that, in the 1930s and 1940s, there were lots of people, by the way. It's very hard to find out who was the first because they were all kind of working on it at the same time. They published papers, and if you glorify one, you're going to do some injustice to someone else according to somebody's opinion. So don't even bother finding out who was the first. All we can do is more or less guess and find out, what papers are out there and work with that. Okay, that's the best you can do today. Anyways, there were several people working on this issue of, especially matter. How did the elements, the chemical elements of the periodic table, how did they come about? Well, you had one fellow, prominent, Hans Bethe, and he said, well, a lot of these heavy elements were manufactured in stars. Okay, through a fusion process. Fusion, fission, they discussed different things. But primarily, I think it was through fusion that they had in mind. Pressure, compressing whatever was in the center of the sun, hydrogen atoms into helium, and later on into heavier elements. But the question that remained is, how did hydrogen come about? Because you can't create hydrogen inside the sun. You can probably create iron in there, no problem. You fuse a lot of atoms together, you create this massive atom. Fine. How did hydrogen, the building block, how was that one created? That created a problem, right? For that, you kind of needed God say, okay, I make the hydrogen atom, now you can do whatever you want with it. Okay, so what happened was they had this idea. On the one hand, they had the other idea of the Big Bang that was coming into, it was blossoming, okay? And so they said, well, maybe that's the type of pressure, heat, and gravity and whatever energy needed to make a hydrogen atom. And so instead of looking at the stars, they said, we got to go to the origin of the universe. Okay? So they said, maybe there we had the pressures, the heat, the gravity, etc., needed to make the hydrogen atom. But then what came before the hydrogen atom? What was the material needed to make the hydrogen atom? Okay, and so this is what they were working on. A lot of people were working on this, okay, within mathematical physics. What they were doing is equations. And here's one of the milestones that came out, 1948, okay? And it's known on the one hand as the alpha, beta, gamma paper because the three people who were put down as authors, alpha, beta, and gamma, alpha, beta, gamma, that's where they got that from. And you can see the title of the paper, The Origin of Chemical Elements. Okay, so this was a milestone because suddenly these people said, look, we can tell you how all elements came to be, especially hydrogen. Okay, and I'm just going to read a couple lines there. It says, various nuclear species must have originated not as the result of an equilibrium corresponding to a certain temperature and density, but rather as a consequence of a continuous buildup process arrested by a rapid expansion and cooling of the primordial matter. In other words, they're saying it wasn't just temperature and density. It was a question of time as the universe expanded that allowed the pressure to decrease, and suddenly you had these neutrons that were able to split between their protons and their electrons. And that's how the atom was created, from neutrons. There was like a gas of neutrons. He says that on the last line. We must imagine the early stage of matter as a highly compressed neutron gas. So there was this neutron gas, it was highly compressed. Now suddenly, because of the expansion of the universe, there's not as much pressure, and now each neutron is able to separate the electron from its proton, and because remember that neutron has more or less the mass of an atom, right? So now you have the proton and the electron, suddenly you have atoms. What is that atom? The hydrogen atom, okay? So this is what they were trying to figure out. It said, we started decaying into protons and electrons when the gas pressure fell down as the result of universal expansion, okay? And this group also put out a little graph that made them famous because it allowed them to convince their peers that they could explain the relative abundance of the chemical elements thanks to this, to the math and to the proposal, to the theory. Okay, so this is why they became quite famous. The alpha, beta, gamma people, because they said, look, we have a very compressed neutron. It's in this gaseous state. As the universe expands, there's less pressure, and now these neutrons disassociate themselves, and suddenly you have protons and electrons. For the first time now you have your hydrogen atom. You see how this went about. So not only did this convince a lot of mathematicians that, okay, we have a solution for how the hydrogen and all the chemical elements came about, but again, it reinforced the notion that there was an origin to the universe, that there had been a Big Bang. Okay, that was so they killed kind of two birds with one stone with this this paper and others that came right after. Okay, so around this time, Mr. Peebles comes around. Okay, and that's you can see some of his bibliography. You can see what he wrote, and you can see just the titles in red there. He talked about in the last 30 years, he talked about Big Bang, the cosmic microwave background radiation, dark matter, right? Like that other one, gravitationally produced matter. You're going to produce matter with gravity. Okay? And just produce it out of thin air, I guess, right? Dark matter, dark energy, black holes. So you can see what his expertise is in, okay? And this is his famous paper. And what I want you to concentrate on, because it's important for political reasons, as I call it, you see the names there on the third line, Penzias and Wilson. They got a Nobel Prize for discovering the cosmic background radiation. And you can see it's that was printed in the Astrophysical Journal, July 1965, pages 419 through 421. What was the article that came immediately before that? That article on that same journal? It was the Peebles article, pages 414 through 419. Okay, so and in fact, Penzias and Wilson mention the Peebles article, Didier, Peebles, Roll, and Wilkinson, right, in a companion letter in this issue. Okay, so these people were eventually get the Nobel Prize, for discovering the cosmic background radiation, but the folks who identified it for them were the group headed really by Dick. Peebles was in there, and so he was an important player there, right? And so these people had to wait 55 years for their Nobels, whereas Penzias and Wilson got it a few years later. Okay. Now it's important to note also that in 1990 you have Halton Arp. For those of you who know who he is, he was an important dissident. He was kicked out. He was hounded into oblivion. Came to Germany. Okay. He was kicked out of the United States. Essentially, he had to leave because he wasn't given any time on the telescope. Okay. So a lot of people who know about dissidents know who Halton Arp is, and together with Fred Hoyle, another dissident, they came up with a different view. They said, we discuss evidence to show that the generally accepted view of the Big Bang model for the origin of the universe is unsatisfactory, and they propose, an alternative. But yeah, not everybody agreed, but these people became the dissidents. These people went into oblivion. The mainstream doesn't listen to these folks anymore. Okay, so just be aware of that. Anyways, Peebles, this is what he wrote in his paper, and I'm just going to point out the important part here. And the important part is the origin of matter, of the universe. That's what they were after. Okay, and you can see the authors. Okay, there. And I want to point out that Wilkinson was part of this paper. He's the guy who's going to be named the WMAP, the Wilkinson Microwave Anisotropy Probe, is named after him. He died of cancer, and they named it after him because he was one of the main players for the WMAP idea. Okay, so he was on that paper as well. And a lot of these people would have received their Nobels if they'd still be around. Okay. Anyways, what was the paper about? Was the origin of matter, creation of new matter. And they also suggested, the unification of quantum and Einstein's field equations, general relativity. What? That led to string theory. Okay, so these papers that were coming out in those days, in the 60s, they eventually led to what we call the quantization of space-time. Okay, this is where they thought the solution was, and today we're living with these decisions. Today it's all about string theory, and what is string theory? The quantization of space-time. It's trying to unite the equations of quantum mechanics and somehow trying to fit them into general relativity, which works on the cosmic scale. So that's where we are right now. And so the only issue I've got with Mr. Peebles is for him to explain the mechanism. I want to understand the mechanism of how matter was created. I mean, we've had several people, among them, Stephen Hawking, who says that the matter in the universe started from something called energy. Whatever energy is, well, this energy stuff was floating in there, and it's separated between positive and negative energy, and that's how we ended up with mass and gravity. Fine, perfect, no problem. What does that mean? Please explain the process. I want to know how matter came in from nothing. And again, these people don't start from nothing. Just like Christianity starts from God and said, well, God was there. Well, how did God come into being? Well, we don't know that. We can't understand all of God's ways, but God was there, and then everything just flows from that point on. And general relativity and mathematical physics in general does the same thing. It says, we had energy. We start out with energy. We had to have the smoke, this hazy smoke out there called energy. And then from there, everything proceeded. Well, if there was this energy, how did the energy get in there? And so on. And so we're not answering the question. The question is, how did matter start? What was the starting point? And I want you to go through with me on a thought experiment. Okay, just bear with me for a little while here. I'm going to take you through a thought experiment just so you can see what the problem really is. Okay, and so let's start with God. Okay, we're going to start with the Bible. It says, in the beginning. What was in the beginning? Well, there was God. There was the Spirit of God flowing through the waters. Okay, that's how the Bible starts. So the Bible starts with God, and just like mathematical physics starts with energy. Fine. Okay, so we start with God. That's already a problem because we already have something, and I thought we were going to start with nothing. Okay, that's the first problem. Okay, but let's turn God into let's forget it. Let's concede that just for the sake of argument. We're going to concede God, the existence of God. Period. Let's not even ask the question, okay, where he came from. It's a taboo question, okay, so don't ask it. I don't know where God came from, but he's there, okay? And we're going to give him all the powers available to us. Anything you can dream, God is a wizard. He can do anything, black magic, white magic, blue magic, all kinds of magic, okay? So we're going to give him all the powers that he wants, okay? I mean, here I'm taking it to extreme just to make a point. I'm going to give all the power that God wants. Anything you can dream of, he can do. Anything he can dream of more things than us, fine, he can do it. Okay? He's got absolute power. Okay, so here's the issue. Okay? Here's God, and first he's going to create man, okay? And the issue here is, just this is an example only. He's going to create carbon from silicon, because according to the Bible, it says, and the Lord God formed man of the dust of the ground and breathed into his nostrils the breath of life, and man became a living soul. Well, the dust of the ground is primarily silicon, aluminum, iron's got a lot of elements, one of the least of which is carbon, okay? From there came man, which is primarily carbon, oxygen, and hydrogen and nitrogen, okay? So I guess he's got a terrible breath, a terrible bad breath, a powerful one to be able to do that just with his breath. I mean, we can probably do it with, in a collider, kind of squeeze through fusion, two atoms together and create a different element. But here God did it with a breath. So it just gives you, he's got all the power in the world, anything you can imagine, we're going to concede it to God, okay? Well, what's the issue? We're going to try to create matter for the first time, okay? We want to see the process of how matter came into being. That's what the thought experiment is going to be about. Okay, so here's God, okay? So bear with me for a second. Okay, here's God. He's going to create the universe, okay? He's got his magic wand there, got all the power in the world. He's just going to shake it, abracadabra, and there it is, okay? So he created the universe. Straightforward, okay? Now let's look at this process in a little detail, okay? Here we see the frames of the film. We're pulling it out, and we're going to analyze the frames of the film of how God created the universe. And what I want you to notice here is we got frame 543, and it jumps to 544, the next frame on the film. Now, you can make these frames as small as you want. Each one represents the smallest unit of time you can imagine, that anyone can imagine. You can't imagine it? Well, make it even smaller, okay? Just make it infinitesimally small, and that's the unit of time we're going to use. There's got to be one frame in which there's nothing, and suddenly another frame in which there is something. We're going to name that first one 543 and the second one 544. So here we have God, all-powerful. He can be all-powerful all he wants. The question is, how does he get from 543 to 544? Here we have zero time, okay, because that frame 544 represents the unit of time. There is no motion in that frame, okay? And suddenly you go from nothing to something, okay? And, okay, so God might be able to do it because he's all-powerful. How do you explain it to yourself, okay? Because here you are, God. You meet God one day, and he comes to you, and he says, okay, Joey, here, let me tell you how I created the universe. And I moved my magic wand and said abracadabra, and here we had something. Great. How did you do it? What's the trick? What was the magic trick? And especially when he didn't move a limb, because suddenly there was something, and in that frame in which something appears or is there already, essentially, he doesn't move a limb. He's there just with his stick, right? His magic wand, and he doesn't even move it. It's just there, and suddenly you have something. So we don't understand the process. We cannot understand the mechanism. Even if God came and tried to explain it to us, what would he explain? How would we understand, nothing moving and suddenly having something there? Okay, this is what we cannot explain. Now, if we cannot explain it, even with God the magician, guys who's got all his superpowers, right? What is Mr. Peebles going to explain here? He's going to do it with physics. He's going to do it with mathematics. What's he going to use to explain to us how matter came into being like we just saw here? Okay, and this is what Mr. Peebles says. Okay, he does address that issue, and it's the way it's addressed today to everybody. He says, the first thing to understand about my field is that its name, Big Bang Theory, is quite inappropriate. It connotes the notion of an event and a position, both of which are quite wrong. There is, in fact, no concrete evidence for a giant explosion. See, all this time we all thought Big Bang because the Big Bang sounds like, a hand grenade being thrown out there. And he's saying, no, there is no evidence for an explosion. Oh, okay. So let's see how matter came into being. Maybe he can explain in a little more detail here. He says, it's very unfortunate that one thinks of the beginning, whereas in fact we have no good theory of such a thing as the beginning. Okay, then he started already in the wrong place. I mean, here they took the universe backwards, right, to the Big Bang, and now he's telling us there was no explosion and that there was no beginning. This is an expert telling you this, okay? In contrast, we do have a well-tested theory of evolution from an early state, okay, to the present state, starting with the first few seconds of expansion. In other words, Mr. Peebles doesn't start at frame number 1. He starts at number 2 or something right after that. But he doesn't start at frame number 1, which is the one we're concerned about. We're the one we want to see that first frame, just like we just saw God, in frame 543 and going to 544. We want to see that frame 544, that first frame where matter comes into existence. That's the one we want to see. Literally the first seconds of time which have left cosmological signature referred to as fossils. Okay, great. We don't have a strong test of what happened earlier in time. We have theories, but not tested. Theories, but not tested. Well, I don't know about tested. What is the theory? I want to know the mechanism. So what is the theory? He's saying that there is a theory, but we don't have a theory. We don't have a theory how matter came into being. So it's irrelevant whether it's tested, especially, you can't test a theory if you don't even have a theory. Any bright physicist can make up theories. They could have nothing to do with reality. Yeah, I know. You discover which theories are close to reality by comparing two experiments. We just don't have experimental evidence of what happened earlier. So what is Mr. Whoa, went out of focus there. Get back into focus here in a second, maybe. So here we have, these people say, look, how did we arrive at the Big Bang? Well, they say only in the Big Bang could you produce hydrogen. That's one issue. The other issue is that they said, look, the universe is expanding. We see all these galaxies running away from us. Why? Because they're all redshifted. Redshift is an indication to the mathematical physicists that something is receding from the Earth. Okay, so we have this explosion happening in front of our very own eyes. Okay, they look and they see redshifted stars, redshifted galaxies, redshifted everything. Okay, so what does that mean? If everything was running out from ground zero, well, all you had to do is rewind the tape backwards and you arrive at ground zero. Okay, so we go back in time, we put everything closer together, just calculate the speeds, everything else, and you say, well, about 14 billion years ago, that's when it all began, because that's when everything was lumped into a single singularity, dot, point, whatever you want to call it. Okay, fine. But see, you got to take the movie all the way to frame number 1. You can't stop at number 2 and say, well, I'm going to start my movie, my theory, right? My mechanism, I'm going to start it at frame number 2. No, I want you to start at frame number 1. I want to see the beginning of the movie. I don't want to come into the movie in the middle of the movie. And of course, they don't take it to number 1. And their claim, their alibi, is that we don't have any experimental proof of what happened at frame number 1. But then the question is the theory valid at all? Does it have any merit if they cannot tell us what happened in frame number 1? And I'm not asking them, again, to tell me exactly what happened, like if they knew what happened. No, give me the theories. Just give me any theory that comes to your mind. If they have 10 theories, I want to hear all 10 of them. I want to know what happened at frame number 1, if anyone can conceptualize it for me. Okay? I'm not asking for the truth. I'm asking just for a conceptualization of a mechanism, of a theory of how something came from nothing. And of course, they cannot explain that. They're never going to find any theory, any mechanism for that. And that's why what they harp upon is something else. They say, look, we can tell you what happened after the first few seconds. And they do all these calculations. What? Because they're all tautologies. They all say, look, what kind of temperature do we need for this to happen to hydrogen? Well, we need, I don't know, so many billions of degrees. Okay. What pressures do we need? Well, we need so much pressure. And it's got to be in so much time. So what they do these calculations, they make them fit their so-called predictions, retroactive predictions of what hydrogen would need to come into existence. And so they say, well, okay, hydrogen came from what? From neutron, because what is hydrogen? A proton and an electron. What is a neutron? The same thing, because it's got the same mass. So essentially it's the same thing in their minds. Okay, so they say, well, okay, we had the proton, we had a neutron, it broke up into a proton and an electron. What kind of pressure, what kind of temperature, how much time would we need to do that? And so they calculate that and they, oh, here I have the equation that would show you this. So it's a tautology. Mathematics is a tautology when applied to physics in that sense, when they simply describe something and they say, they just make the equation fit the facts. So it's a tautology. It's nothing more than that. And we don't care about their math. We don't care about their tautology. We want a mechanism. We want to give me a mechanism how matter came into being, into existence. And they say, we don't have proof for that. We don't have any evidence. We can't run an experiment. So it's kind of beyond the ability of science. It's beyond science. It's not a scientific issue. It's a question of the other side of campus, of philosophy. So we can't answer those questions, and because it's not part of our discipline. Our discipline is just to do the equations and show you what happened at the second, not at the first second. So you see how this is being handled. And they're going to continue with that forever. They're going to say, look, we can't tell you what happened at the frame number 1. And again, it's because they cannot conceptualize what happened at frame number 1. So is this Big Bang Theory worth anything? They show it. They have these pretty pictures. What is it worth if they cannot tell you how that little point, how time began, how the first bit of matter came into existence without the energy, without the God and his magic wand behind it? So the other thing it allows out there is for people who believe in God, who propose God as a starting point. They say, well, I know what happened before the Big Bang. It was God, but you guys don't want to admit it, referring to the mathematical physicists. They say, for example, Christians, they'll say, well, you don't want to recognize God. But see, how did that little singularity come into being? How did that energy come into being? And what's the guy going to tell them? He says, well, we don't know. We don't have any proof. We don't have any evidence. We don't have any experiment that we can run. And the other guy says, see, that's where you have to come in with belief, and that's where God comes into the picture. So these people have, after hundreds of years, they ended up all in the same boat. It's like if the Christians took over science, over physics, and they say, yeah, we can tell you we had a beginning to matter, and that bit of matter, well, for these guys, it's energy. We call it God, and everybody shakes hands, drinks champagne, and celebrates. And we still don't have a mechanism how the first bit of matter came into existence. That's where we are today. And that's where we're always going to be until, well, we'll find out until what? In the next few seconds here. So what did these other fellows come in, and what did they get their Nobel Prize for? Their share of the silver medal. Half a silver medal. They came in second place. They split 1/4 of the price apiece. Okay? Well, the only thing I want to mention about the first guy, his name is Michel Mayor. And I want to mention that he received a prize in 2010, the Ambartsumian Prize, okay? And then he received the Kyoto Prize in 2015, and then again in 2019, always for the same thing. And you would think, that they would kind of give a prize to a different person, to someone who invented or discovered something different. They keep giving this guy the same prize, or a prize every 5 years for the same thing that he discovered in 1995, which was apparently the first planet outside the solar system. Well, did he discover it? Did he take a picture of it? Can he show you what he saw? Well, here you see it on the Nobel Prize in Physics 2019. I've got it with a frame there. It says, the presence of a Jupiter mass companion to the star 51 Pegasi is inferred from observations of periodic variations in the star's radial velocity. So they're inferring that there is a Jupiter mass-sized planet over there in this star. It's inferred. They never saw it. They never took a picture of it. They're just measuring. They're saying, okay, it looks like something is wobbling over there, so we're going to call it a planet because it's not massive enough to be a star. We can't see it because it's dark. So it's probably got the mass of Jupiter, but it hasn't ignited to turn into a star, so we'll call it a planet, and that's what they got their Nobel for. And they've had this, and they get a Nobel or a prize every 5 years for this. The only good thing about that is it created a cottage industry in which everybody started looking for exoplanets. That's what astronomers spend their time on now, and they're looking for the planets outside the solar system. Maybe they found, like I said, maybe 5,000, 6,000 planets now, and again, a lot of them indirectly. I don't know if they have a picture of any of them. I don't think they do because it's too dark, too far away. So it's all done by inference. They see a wobbling there and they say, oh, that must be a planet. It's got so much mass, so it's the size of Jupiter, Neptune, Uranus, whatever. And that's it. That's all they do. What is all this work for? What do we need that for? Are we going to make contact with someone in a Jupiter-sized planet? I mean, if it's Jupiter-sized, more likely nobody can live there. Okay? So it's got to be something closer to the Earth, you would think. Smaller, closer to the sun, etc., etc. It's got to have some of the specifications that our planet has if we're going to make some sense out of it. And then the other issue is, well, is there anybody there? I mean, if there's nobody there, who cares if there's a rock going around another planet, another star? We can imagine that going, we don't have to look it through our telescopes. We can imagine that there are a bunch of planets out there rolling around their stars. So what? I don't need to see them. I can imagine them. Fine, great. And what do we do with that? We got rocks going around stars. And is this what we're paying these guys for, these astronomers, to go look for, dead planets? I mean, what's the point of that unless maybe, you contact another civilization? That might be a little bit exciting, So the question is whether that is even within the laws of probability. And that's what I'm going to discuss next. Why? Because his buddy, which was a student and got the other quarter of the prize, it's this fellow, Didier Queloz, this fellow here, and he says the following. Okay, he says he predicted humans will discover extraterrestrial life, ET life, in the next 30 years, stating, I can't believe we are the only living entity in the universe. Okay, there are just way too many planets, way too many stars, and the chemistry is universal. The chemistry that led to life has to happen elsewhere. So I am a strong believer that there must be life elsewhere. Okay, I don't have a problem with that. I believe he's correct. I mean, I think with so many planets out there, for sure, there's got to be life out there. What does that help us? Again, Fermi's paradox. Why hasn't anyone contacted us? Hasn't there been anyone superior to us that developed better technology that could at least contact us? Why wouldn't they? Well, what would be the problem there? Okay, why haven't we been contacted? Or maybe we have, I don't know. And here are, if you look it up, you'll find that this is from the Wikipedia, gives you some of the reasons or some of the theories kicked around for why we haven't been contacted. Okay, extraterrestrial life is rare or non-existence. Intelligence is rare or non-existence, especially in mathematical physics. Periodic extinction by natural events. Again, people thinking of catastrophes, or the next line, intelligent life will destroy itself. So they think of in these terms. Where do we get these ideas? Well, they get them from paleontology that says, well, dinosaurs died what? Because probably an asteroid hit us. And if it wasn't that, in the case of humans, if it's not an asteroid, then what else could kill us? Well, it would be, us committing suicide, or, we killed each other. That's one issue. And the other issue, a catastrophe, some other catastrophe of some kind. Okay, so that's all they can think of, especially, climate change and those things that are out in the news. What else can these people think about? So this is what is going through their minds. So they're saying, why hasn't another civilization contacted us? Well, perhaps they died. They killed themselves, or they had some kind of accident, some catastrophe happened to them. Okay, so it happens to all civilizations. This is what you got to think about. Intelligent says it is the nature of intelligent life to destroy others, not only to destroy itself but also to destroy others. So thank God they haven't contacted us because they might kill us. Okay, they haven't developed advanced technologies. They says civilizations only broadcast detectable signals for a brief period of time. That one I didn't understand because I'm thinking, what do you mean a brief period of time? You mean until they die, until they become extinct? Is that what you're talking about? Because otherwise they could continue, transmitting. Or, they probably have communication of some kind. All those waves should be coming towards us, right? Life may be too alien. You can't even detect it, okay? Colonization is not a cosmic norm. I don't know why that. You've got SpaceX. They're trying to conquer Mars. Why wouldn't they try to conquer the nearest star and the galaxy eventually? Sure they would. Okay, so, I don't buy some of these arguments that these people make. Alien species may have only settled part of the galaxy. Yeah, they're on the other side of the galaxy, not on this side. Alien species may not live on planets. Where do they live? On asteroids? I mean, some of these answers, you kind of wonder about the mental state of some of these people. Okay, and it doesn't stop there. There's a second group here of issues, and I'll just run them through quickly. Alien species may isolate themselves from the outside world. Lack of resources, money, needed to physically spread throughout the galaxy. We haven't listened properly. We haven't listened for long enough. Intelligent life may be too far away. Okay, that's very possible. Okay, that's a possibility. I think it's the only one so far. Okay, intelligent life may be too far away. Intelligent life may exist hidden from view. Well, yeah, the point is, you got to try to locate it. Okay, and if you've got signals of some kind, we should be able to detect them. Okay, everyone is listening, but no one is transmitting. Communication is dangerous. See, you could be contacting someone. They say, oh, these people now have the technology to contact us. We got to go out there and kill them before they conquer us. It's like more advanced civilization kills a less advanced civilization, that sort of thing. Okay. Earth is deliberately not contacted. And what they have in mind there is that they say, we don't want, if we find life on Mars, some bug or some unimaginable thing crawling there, you say, well, leave it alone. Let it evolve. Let it do its own thing. We're just going to observe it, but we're not going to intervene. We're not going to do anything with it. We're going to let it follow its own course, natural course. So this is what they're referring to. Like, they're watching us, and they say, we don't want to intervene. Let the humans evolve, develop their planet the way they want, develop their technology, whatever, but we're not going to intervene on their planet. Okay? And so this is the idea behind that. Okay? Earth is deliberately isolated. Again, similar thing. Okay? Beings may have created this simulation so that the universe appears to be empty of other life. In other words, we have been created by some other civilization. These are the ideas people have out there. And alien life is already here, unacknowledged. These are the UFO people. They say, hey, they're here. They're all in the asylum. Okay, so let's answer the question. The issue is another one. The issue is staggering. That's what it is. What you have is humans only live for a very short while. Okay? Intelligence, not because we destroy ourselves, but because our economy doesn't allow us to go beyond a certain point. At some point, our economy collapses. When that happens, we're no longer alive. We become extinct. And I think that's going to come very soon. If we grant that as a theory, right? We're going to accept that as an assumption. That means that intelligent life of the nature, such as human intelligence, which I'd say is the maximum you can achieve in the universe, because anything that the Klingons or God wants to explain to us, we will understand. Most of the people on the planet will understand, especially if you put it in pictures out there on the wall and say, look, this is how we created matter, etc. We're going to be able to understand it if someone explains it to us. Okay, there is no supernatural intelligence. We should be able to understand just by watching what these people are trying to tell us. So ours is the maximum intelligence in the universe, but we've only had the technology that we have for like transmitting and so on for maybe 200 years at most. Okay, you want 300 years? I'll give 300 years. Let's assume we have the last 300 years of our lives, of our existence. We had technology to transmit and receive electronic signals and so on. That's not even a drop of water in the cosmic ocean of time. So, we're staggered. We live these 300 years, we die, and then some other civilization pops up in another planet, even nearby, it doesn't matter. If they try to contact us, what are they going to find? Well, they're going to find, there's no retransmit, no one hearing them because we're all dead. We're not around anymore. And then that happens to that civilization, to another one, to another one. So they're all staggered in time, aside from distance, and aside from the very few planets proportionally that have life. And again, I'm saying that very few planets harbor life because carbon is not the most abundant element, in the universe. First, second, it's not even the most abundant chemical element here on Earth. You have a lot more silicon, you have a lot more aluminum, iron, other elements which are much more popular than carbon. And so life has to be a scarce resource in the universe. First, because it's not the most common element. Carbon is not the most common element. You need carbon to make life. There are no silicon creatures out there. And I know this because here in the solar system, we got a lot of silicon. And it's very strange that nothing came out of those silicon creatures. No creatures came out, made out of silicon. And that is suspicious. That should give us a clue that there are no living entities made out of silicon. That's my take on that. And so if we're talking about carbon, we're talking about scarcity of life in the universe to begin with. And then we have distance, and then we have time. And those are the limiting factors. The other issue is that we cannot travel even to the nearest star. The nearest star is 4.5 light years away. We're never going to make it there. Certainly, we're not going to colonize or conquer it or even go there. We can't even make it to Mars, and then it's pretty much over for us. And so everybody is stuck within their solar system, within their star system. That's my take on that. So there's no chance of us conquering another planet, let alone communicating with another planet. First, because we're separated by distance, and we're staggered in time in when one civilization pops up, dies, and then another one rises, and then another one, and then another one, and another one, and so on down the line. So this is what's preventing us from, communicating with another civilization, also known as Fermi's paradox. I don't think we can ever overcome Fermi's paradox. Okay, the reason we have not been contacted and never will be contacted in what little time remains for us here on Earth is that we're staggered in space and time primarily, but aside from the scarcity of life to begin with.